I am Priyashish, studying second year in EC department of third sem. Now, I would like to talk about my TikTok topic of subject Digital System Design, and the topic is first updating algorithms for TCAM. Introduction to TCAM. TCAM or ternary content addressable memory is a type of memory used for high-speed data retrieval. It allows for three states 0, 1, and don't care, enabling flexible matching of data. TCAM is commonly used in networking devices for tasks like IP routing and packet classification. TCAM IP lookup example. Here we can see the destination IP address, location memory 123 and bit vector, and also memory location priority encoder, and at last action memory and next hop. The adoption of classes inter interdomain routing in 1993 required a routing lookup to perform a longest prefix match operation. A router maintains a set of destination addresses prefixes in a forwarding table given in a packet. The operations finding the longest prefix in the forwarding table that matches the first few bits of packet's destination address. To provide enhanced services such as packet filtering, traffic shaping, policy-based routing, and so on. Routers also must be able to recognize flows. A flow is a set of packets that obey some rules called a policy on the packet's header fields. This is the introduction of TCAM. TCAM stands for Ternary Content Addressable Memory. Now here we can see about the need for fast updating TCAM. Fast updates in TCAM are crucial for real-time applications such as network security and also traffic management. Traditionally, the memory structures and struggle to keep the pace with dynamic changes in network conditions. Quick updates minimize the latency experienced by users and devices relying on the immediate data access. Here we can see the first search broadcast and the search word and the data's word and then search result. This is how it works. Now moving on to next slide. Here we have the challenges of TCAM updates. Most of the updates are costly in terms of power consumption and in chip area compared to other memory types. The inherent complexity of ternary matching leads to longer update time when modifying entries. Ensuring data structure consistency during rapid updates and possesses significant technical challenges. There are some pros and cons as everything has. Now the TCAM also has some pros and some cons. Now let's see about the pros. Advantages. Industry vendors are providing cheaper and faster TCAM products. TCAM architecture is easy to understand and simple to manage in updating TCAM entries. TCAM's performance is deterministic, and there are some cons. There, a TCAM is less dense than a RAM, storing fewer bits in the same chip area. TCAM dissipates more power than RAM solutions, not straightforward to store ranges. Example 0,3 equals to 00 star star. So that's the disadvantage of the TCA. Moving on to next slide, we have overview of fast updating algorithms. Fast update algorithms are designed to optimize the speed of TCAM entries updates. These algorithms focus on minimizing the overhead associated with reconfiguration of TCAM contents. As a result, the problems of routing lookup and packet classification have recently received the considerable attention, both in academia and industry. For example, the literature for solution of the routing lookup problem and for solutions to the packet classification problem. Many of these reports have indicated the difficulty of general multidimensional packet classification packet in the worst case. Hardware realization of algorithm simply solutions such as linear or fully associative searches have favor in some commercial deployments. Fast update algorithms for TCAU. It is also one of the IEEE topic. So moving on to next, we have segmented update algorithms. Segmented update algorithms, partition partition the TCAM into smaller segments for more efficient updates. By localizing changes, these algorithms reduce the time required for complete TCAM reconfiguration. This method allows for stimulation updates and improving overall throughput and responsiveness. Best practices for implementing customer segmentation algorithms: collect relevant data, define segmentation criteria, and the next is choose the right algorithm, and the next is validate and refine the segments and personalize marketing campaigns, and at last monitor and adapt. This is how segmented algorithm updates works. Now moving on to the another topic, incremental update techniques. Incremental update techniques modify only the affected entries rather than the entire TCAM structure. They can track changes and apply updates in a manner that conserves a resource and time. This method is particularly effective in environments with frequent but small changes to the set of data. Incremental update has header, body, trailer, body, and original file and upcoming file. And each cell in DCAM can take three logic states: 0, 1, or don't care, as we said before. A CAM allows a fully parallel search of the forwarding table or a classifier database. The ternary capacity lets the TCAM store wildcards and variable length prefixes by storing don't cares. Lookup are performed in TCAM are actually forwarding tables in entries in order to decrease the prefix length and choosing the first entry among all the entries that match the incoming packet's destination addresses. This is how incremental update techniques goes in TCA. Now let's talk about the hybrid approaches in it. Hybrid approaches combine multiple update strategies to leverage their strengths. This can involve integrating both segmented and incremental techniques for optimal performance. Hybrid algorithms can efficiently balance speed, resource consumption, and complexity. It turns out that it isn't necessary to keep all the forwarding table entries in order to decrease prefix lengths. Instead, only leveraging lapping prefixes and need to be in this order. Two prefixes overlap if one is a prefix or to other. For example, 01 star overlaps with 0101 star, but with 001 star. This observation is used in the second algorithm. Although not proved, this algorithm seems to be optimal in the number of worst case memory operations required to handle a forwarding table update. As you can see, the hybrid project management process requires project brief and requirements. It kicks off and planned communications like stand-ups, sprint planning, retro retrospectives, and status updates. And here we have performance of their metrics. Performance of fast and updating algorithms is measured in terms of speed, efficiency, and resource usage. These metrics include update latency, throughput, and memory utilization. Evaluating these metrics helps in determining the most effective algorithms for specific applications. There are four types of performance metrics. They are business performance metrics and project management metrics, and we have the another two are employee and sales performance metrics. These are the type of performance metrics we have. And the next is real world applications. Fast updating algorithms for TCAM are widely used in routers and switches for efficient packet processing. They are also critical in cyber security applications where dynamic rule updates are essential for threat management. Additionally, advancements in these algorithms can enhance the performance of cloud computing and data centers. And this is about the real world applications. Next, we have future directions. Research is ongoing to develop even faster, more efficient updating algorithms for TCA. And the future directions include incorporating the machine learning techniques to predict and manage updates. The integration of TCAM with emerging technologies such as hardware accelerators is also a key of interest. And then here we have by the controller, it gives update policy and then next to rules generation and to input queue. And that's how the switch and it goes to physical TCAM. also known as TCAM. And here comes the conclusion of the today's topic. Fast updating algorithms for TCAM are a vital high maintaining performance in dynamic environments. Continued innovation in this field will support the growing demands of networking and data processing applications. Emphasizing both speed and efficiency will be crucial as TCAM technologies evolves. So this is about the fast updating fast updating algorithms for TCAM. Thank you.